Hello all, welcome to my channel. Let's start with part 4 today, that is factors on which the resistance of a conductor depends. Like now we can use different types of conductor in place of X and Y. Here you can see we have an electrical circuit which has a cell, which has an emitter, which has a key and which has a XY. XY is a place where I would going to put different types of conductors of different length, different material, different area. So when we put, suppose let us say that I have a nichrome wire of 5 meter and I have a nichrome wire of 10 meter. So when I put a nichrome wire of 5 meter here between XY box, then we can see that the emitter reading is, suppose emitter reading is 5 ampere. Now, if I put a 10 meter wire here, then the emitter reading would be changed. Why changed? That means there is some change in the resistance. Like if we are using nichrome wire of 5 meter and if we are using a nichrome wire of 10 meter, that means there is some resistance change. That's why the current has been changed. So as you know that it is dependent on VIR. So if there is change in resistance, there will be change in the voltage and there will be change in a current as well. So that's about nichrome wire, and that means the resistance is dependent on the length of the wire. So the first thing is length of the wire. Resistance depend on length of the wire. And it was found after many experiments that the resistance is directly proportional to the length. Now the second thing, I would be taking two different wires that have different area. Let's take nichrome wire again, and suppose it has an area of 5 meter square and another wire having 10 meter square. And it was found when we put a 5 meter square wire, meter square, that means I'm talking about area. So if I am putting a thick wire as compared to the 10 meter square one, then the resistance will be higher, because it was found that if we compare resistance and area, they are inversely proportional. That means R is inversely proportional to the area. Let me write this. Now what does this mean? If we increase area of any conductor or anything, that means the resistance will be decreasing because it is in inverse proportion. That resistance will be decreasing. Now if I consider that my area is decreasing, then the resistance will increase because they are inversely proportional to it. So that's about resistance and resistance based on length and resistance based on area. Now the third quantity is the type of material we are using. That means nature of material we are taking. Like we might take copper wire, nichrome wire, aluminium wire, anything we can choose. So all different materials will have different resistance because their conductivity varies. So therefore the third thing is material or nature of material. So first is on length, second is on area, third is on material. So let's make a formula out of these all. So using these above, we can write R is proportional to L over A. Now, when we remove a proportionality sign, then we get a constant here. And constant in this case is denoted by rho. Rho, and its name is resistivity. Now, you might have a question like why we have rho here now. when we have R as resistance. Now why we have a resistivity here? So the resistivity is actually different from resistance, as you know that the resistance is measured in ohm and resistivity is measured in ohm meter. So that means it is dependent on length as well. Electrical resistivity depends on ohm meter. So that's about factors on which the resistance of a conductor depends. So thank you for watching this video. I will cover the next topic of resistance of a system of resistors, that is in series, resistors in series and parallel. So I will be talking about that in next lecture. Thank you for watching this video. Have a great day.